Looking at 7D.3, our mastery learning objective is I can solve real-world problems involving angle of elevation by applying trigonometric equations. So we're really just doing real-world problems using what we just did in 7D1 and 7D2. Okay, we're now going to be solving. So, what is an angle of elevation? An angle of elevation is the upwards angle from the horizontal to the line of sight of the observer. So basically, here's our little observer, it's our guy, he's looking at this balloon. So the horizontal is down here, and his line of sight, right, if you imagined a line straight from his eyes to the object, so the angle from the horizontal to that line of sight. Right, that's what we call an angle of elevation. It's going up, like an elevator. Alright, so let's look at some examples. The first thing that we always want to do is draw a diagram. And by diagram, I mean, we're going to write today. We are just always going to draw a right triangle. So our diagram, these are always going to be a right triangle. So looking at example 1, the angle of elevation from a kicker's foot on the football field to the top of the goalpost is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So I'm going to draw my triangle. Alright, triangle. So I have a foot here. Alright, this is the top of the goalpost. And this is the base of the goalpost. Okay, so I'm just going to kind of label the pieces of my drawing. Once I have what my drawing is representing, then it makes it easier to just put my numbers in. So angle of elevation, again, this is my angle of elevation. And it says it's 17 degrees. And he is standing 131 feet from the base. So him to the base is 131 feet. And then how tall is the goalpost? So now, we're just solving this, just like we did before. So I'm going to label my sides. I have my hypotenuse over here, my opposite, and my adjacent side. The sides I need to use are the opposite and the adjacent. So I'm using SOHCAHTOA. Tangent uses opposite and adjacent. So tangent of theta equals O over A. So tangent of 17 degrees equals the opposite side is just my x, and my adjacent side is 131. If I put that over 1, I'm cross multiplying. So I have x equals 131 times the tangent of 17 degrees. When I type that in the calculator, I get 40 feet. And that's it. Okay, so it's exactly the same as what we've been doing in our last one. It's just now word problems. We have to draw our own picture. All right, looking at example 2. Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees, and the slide has a vertical height of 9 feet, find the length of the slide. So again, now I'm just going to draw my right triangle, just like this. So this is going to be Mom. This is where the top of the slide is. Right, and that's about all we know. So if the angle of elevation from the bottom of the slide to the top, so my angle of elevation is 46 degrees. So yeah, that's going up like that. And the slide has a vertical height of 9 feet. And I don't know why I put X there. 9. Find the length of the slide. Well, if I'm sliding down, which the top of the slide, where Leah is up here, she slides down to Mom, right? It's that diagonal distance, X, for this slide. So again, labeling O, A, and H. Across from my right angle is my hypotenuse. Across from my angle is the opposite, and my adjacent side. So I'm using my opposite and my hypotenuse and looking at. So Katoa, opposite and hypotenuse is sine. So sine of theta equals 9 over x. So sine of 17 degrees equals, opposite, hypotenuse. So sine of 17 degrees equals 9 over x. I'll put my angle over 1 and cross multiply. So I have x times the sine of 17 degrees equals 9 times 1, which is 9. And then since x is being multiplied by something, I'm going to do the opposite, and I'm going to divide. I'm not using 17, I'm using the number from the last. This should all be, all of these should be a 46. Sorry. I was using the angle from the last problem. So sine of 46. 9 divided by the sine of 46 is 12.5 feet. So our slide is 12.5 feet long. All right, looking at example 3, KC sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. How far is KC standing from the base of the lighthouse? So our lovely picture, right? Drawing our triangle. Okay, so KC is over here. Then I have the top of the lighthouse, right? We'll call it like LH for lighthouse, and the base of the lighthouse. Right. Base just means bottom. So putting in my numbers, we have Casey sights the top of an 84-foot tall lighthouse. So my lighthouse is 84 feet tall, from top to bottom. My angle of elevation is 58 degrees, so my angle going up is 58 degrees. I'll try to use the right angle this time. And then how far is Casey standing from the base of the lighthouse? Okay, so Casey's at the base. That's where I'm going to put my variable. All right, labeling my sides. I have my hypotenuse. The opposite side and the adjacent side. Those are the two that I want to use. So again, looking at Katoa. Alright, I have an O and an A, so I'm going to be using tangent. Tangent of theta equals O over A. So tangent of 58 degrees equals 84 over x. Over 1, I'm going to cross multiply, right? So I have x times the tangent of 58 degrees equals 1 times 84, which is 84. And then again, since x is being multiplied by something, alright, I'm going to divide by the tangent of 58 degrees. When I do that, I get x equals 53.1. Alright, our last problem. A dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? A right triangle. So I have a dog, the base of the tree, and then the cat is up in the tree, right? So a dog is standing 5 feet from the base of the tree. So I'm going to put a 5 here. And then looking up at a cat that has climbed 16 feet up the tree. So the cat is 16 feet up. Okay. What is the angle of elevation? Okay, so I'm looking for that x. Again, we'll start by labeling OA and H. And that is the opposite side and my adjacent side. Again, I'm going to be using O and A, which, as we saw from up here, is tangent. So, tangent of theta equals O over A. In this case, tangent of, what I'm looking for is the variable, or for the angle, so tangent of x equals 16 over 5. And then this is where I just use my inverse trig ratio, that inverse tangent. X equals inverse tangent with a little negative 1 of 16 over 5. And that angle is 72.6 degrees. And that is it. Go ahead, work on your 7D.3 activity.